In this video, we are going to set up the environment that is needed for our Route 53 lab. I am going to register a domain to demonstrate the Route 53 routing policies. You don't have to do this because this incurs cost, but you are welcome to just watch and learn. Go to Route 53. Under the domain registration, click on Get Started Now. Click on Register Domain. Now here you can choose a domain that you want. I'm going to select WizLabs Test. The wizlabstest.com domain is available, so I'm going to add it to cart and I'm going to purchase it. I'm going to fill up all the information and hit continue. On this screen, it will ask you to check the contact details. Just verify. Now at this stage, you will receive an email from Amazon registrar to verify the email address to register the domain with Route 53. So go ahead and click on the verification link, then come back to this screen and click complete purchase. Once you verify your email using that link, you should get a message confirming the email address verification. Now at this stage, click on Go to Domains. The current status is domain registration in progress. After just a few minutes, you should be getting an email confirming that the WizLabs test or whichever your domain is registered successfully. Now go back to the Route 53 and under pending request, if you go back and refresh, you should see that there is no more any pending request, and if you click on the registered domains, your domain should be registered successfully and should be available for you. Hi there. In this video, we are going to learn about simple routing policy that is offered by Route 53. And as the name suggests, this type of routing is really simple. So what is a simple routing policy? This policy basically routes the traffic to a single resource. For example, it could be an elastic load balancer or an IP address of a web server. In this policy, you cannot create multiple records that have the same name and type, but you can specify multiple values in the same record. For example, you can create an A record which will have multiple IP addresses. If you specify multiple values such as IP addresses in a record, Route 53 is going to return all these values or IP addresses in random order to the originator of the DNS query. Now in simple routing policy, you can create two types of records. First is an alias record. In this, the endpoint would be an AWS resource such as an elastic load balancer or CloudFront distribution, etc. You can attach a health check with this record. The other type of record that you can create is a basic or non-alias record. In this record, typically you specify IP addresses of individual web servers. Now note that you cannot attach a health check to this record. Route 53 will return all values to the client regardless of the status of the IP address. So it might happen that an IP address of an unhealthy instance is returned. The client tries to connect to that unhealthy IP address and then it may experience downtime. It's possible with this record. Now, a typical scenario would be a simple static website that sends traffic to a load balancer that has many web servers behind it. Now, let's take a couple of examples of simple routing policy. In the first scenario, we are going to create an alias record that will be pointing to an elastic load balancer. That load balancer will have a couple of instances behind it. Note that you can attach a health check with this alias record. I am in AWS Console and I have created 4 EC2 instances. Instance 1, 2, 3 and 4. Now if I open their public IP addresses in web browser, all they are doing is just displaying the number associated with that instance. So I have instance 1, instance 2, instance 3 and instance 4. Very simple. I have also created a load balancer which is just an application load balancer. It has an associated target. This target group has couple of targets associated with it, instance 1 and instance 2, and both are healthy. Now if I open this load balancer's DNS, you can see that it is going to balance the traffic between instance 1 and 2 as expected. Now let's go to Route 53. Now here I have registered a domain which is wizlabstest.com. So it has gone ahead and created a hosted zone for me. What is a hosted zone? Well, a hosted zone is just a central repository or a container in which you can create multiple record sets. And remember that a record set contains the logic of routing the traffic. Just in case you have not registered a domain, you can simply create a hosted zone by clicking here, giving it a name, and selecting a type. The public hosted zone is reachable via internet, whereas a private hosted zone can only be reached within an Amazon VPC. So you can go ahead and create a public hosted zone. In my case, I already have one created. So I'm going to open it. Now note that a hosted zone, whenever you create it, always comes up with two default records. One is an NS record and other is an SOA record. So what is an NS record? The NS record or name server record specifies the servers which are providing DNS services for that domain name. So in my case, I have these servers which will be providing the DNS services for my wizlabstest.com. There is another record which is called as SOA record. SOA or start of authority record is basically just an information stored in a DNS zone about that particular zone and about the other DNS records. So if you click on it, you can see that it has the information about start of authority, that is authority domain, the domain of the zone admin, that is its email address, and this is actually AWS DNS-hostmaster at amazon.com. It also has zone serial number, refresh time, retry time, expire time, and negative caching time to live. Now for this course, I'm not going to go into much detail of start of authority record, but just remember that each zone must have one SOA record. The TTL or time to live is a time span in seconds for which this mapping will be valid when it gets cached. So after the TTL expires, the name server will resend the DNS query asking to resolve the website or the IP address. Now let's go ahead and create our record set. Now here, if we do not give any name here or do not give any prefix here, the rest of the domain is called as zone apex. And you can create a record set for zone apex or you can create any subdomain. So if I create www, the whole string will become a subdomain. Now let's go ahead and create a record set for zone apex. There are many types of record which you can create. For this example, I'm going to create an A record. I'm going to create an alias and the endpoint or the target name is going to be the Elastic Load Balancer. You can also choose an S3 website endpoint or Elastic Load Balancer or CloudFront distribution or Elastic Beanstalk environment. Let's go ahead and select the Elastic Load Balancer. The routing policy is going to be simple, and for now, let's just keep the evaluation of the target health as no. Go ahead and create it. So with this record set, whenever a user goes to wizlabstest.com, the traffic is going to be routed to the Elastic Load Balancer. Let's go ahead and try that out. So open a new browser and go to the website. And there you go. You can see that the traffic is now going to the Elastic Load Balancer, which is balancing it amongst the two instances. Now let's go to our second scenario. In the second scenario, we are going to create an A record, which is not an alias record, it's just a basic record, which will have the IP addresses of instance 3 and instance 4. Now note that since it is not an alias record, it will not have any health check associated with it. So let's go back to root 53, delete this record. Remember that you cannot create two records having the same type and same name. So we have to delete this, create a new record set, keep the name as the zone apex. The type will be an A record and we are not going to alias it. So first we will set the TTL, and instead of 300 I'm going to set it as 30. You can choose whichever value you like. Now the values are going to be the IP addresses of instance 3 and 4. Keep the routing policy as simple and create it. So with this record, whenever a user will go to vislabstest.com, the traffic is going to flow between these two instances. Now note that whenever a DNS query comes for vislabstest.com, both the IP addresses are going to be returned as the answer to that query. Now let's go ahead and test this. And there you go. If you refresh it, the traffic is now going to instance 4. Now why is it not going to instance 3? It may or it may not go because the IP addresses that have been returned, the client is using the IP address of instance 4. Now as long as it is finding it as healthy, it may not route the traffic to instance 3. So the traffic is going to instance 4 only at the moment. Now let's try one thing. We will go ahead and make this instance as unhealthy. Then the traffic should go to instance 3, right? Let's go ahead and try it. Let's go to EC2 and we are going to stop the instance 4. The instance 4 is now stopped. So let's go back to our website and see if the traffic gets routed to instance 3. And there you go. The traffic is now getting routed to instance 3. So that's the gist of simple routing policy. The logic is very simple. You just define the endpoint and the traffic will just go to that endpoint. Hello again. In this video, we are going to learn about weighted routing policy. We saw in the simple routing policy that route 53 simply forwards the traffic to the targets that we defined. However, what if the user wants to control how much traffic should go to a particular IP address? That is exactly what this policy does. The weighted routing policy basically lets you associate multiple resources with a single domain name or a subdomain name and choose how much traffic should get routed to each resource. How does it do it? Well, it allows you to create records that have the same name and type for each of your resources, something that was not allowed in the simple routing policy. In this policy, you assign each record a relative weight that corresponds with how much traffic you want to send to each resource. So in other words, you define how much weightage to give to each record. The traffic routed to a resource is calculated as the ratio of the weight of that specific record and the sum of the weights of all the records. We will see an example in a minute. Now the scenario in which this is useful is, let's say you want to test a new version of the software and route only some portion of the traffic to the resources having the new version and remaining portion to the old production version. Now to demonstrate how weighted routing policy works, I will be creating two alias records with the same name. In the first alias record, I'm going to create an elastic load balancer as the target, which will have a couple of instances behind it. I am going to assign it a weight of 7. There is no unit to it, just number 7. I'm going to create another alias record with the same name and same type, which will have a target of elastic load balancer, which will have couple of instances behind it as well. I'm going to assign it a weight of 3. Now, the traffic that will be routed to the first elastic load balancer will be 70%. How did we calculate that? We'll just take the weight of that alias record divided by the total weight, which is 10. So 7 by 10 will be 70%. So approximately 70% traffic should go to the first elastic load balancer. And the remaining 3 by 10, that is 30% of the traffic, should go to the second elastic load balancer. Let's go ahead and set this up. In the AWS console, I have set up 4 instances and 2 load balancers. The 4 instances simply show the digit associated with that instance. Instance 1, instance 2, instance 3 and instance 4. Very simple. The first elastic load balancer, which is R53-ELB, balances the traffic between instance 1 and instance 2. The second elastic load balancer, which is R53-ELB-2, balances the traffic between instance 3 and instance 4. Now let's go to the Route 53 console. Let's go ahead and clear any existing record. Let's go ahead and create a record. I'm going to use zone apex. The type will be an A record. The first record will have a target of the first elastic load balancer. The routing policy will be weighted. The weight will be 7. Now I'm going to give a set ID which will uniquely identify this record amongst the others. Just give it a name. For now, evaluation of target health, set it to no, and associate with health check, set it to no as well. Go ahead and create it. Now add the second record. Alias it to the second load balancer. Select routing policy. Give the weight as 3 and give it the set ID. Click create. So we have set up our record set. Now let's go ahead and test this. Now if you count the number of refresh and see the pattern of how much traffic goes to instance 1 and 2 compared to instance 3 and 4. And you can see that the maximum traffic is getting routed to instance 1 and instance 2. Now one thing to note that you do not have to have this weight in the multiples of 10 or 100. Let us take another example. In this scenario, we have set up 3 alias records, each one having its different weight. The total in this case is 15. It does not have to be 100. So in the first alias record, 20% of the traffic will go to the first elastic load balancer. 33.3% traffic will go to the second load balancer, and remaining 46.7% traffic will go to the third elastic load balancer. Now, one question comes up is that why was it not in the multiple of hundreds, or why couldn't you give weightage in terms of percentage, right? Well, the reason being that if you have multiple records, and let's say if we had given 30, 50 and 70, if we delete one of the records, let's say we delete the record of 70, then the total will be just 80, right? It will not be 100. In that case, we will have to rebalance the weight of the first two records. To avoid that, the formula is based on the total weight rather than any percentage. And that's why the formula is based on the total weight of all the records rather than on the base of 100. Now, one question always comes up is that what if you have not purchased any domain, or you have been so far using only the test hosted zones? There is a way to test your records without having to go to the internet. Use this option to test your record set. Click on it. This has the name of your hosted zone. Keep the record name as blank and select the type as a record. Keep the resolver IP address as is and click Get Response. Now for this query, the Route 53 has responded with couple of IP addresses. These IP addresses belong to one of your elastic load balancers. So if you open one of these IP addresses, you will see that it will balance the traffic between instance 1 and instance 2. If you open the other IP address, it is going to do the same. So these two IP addresses belong to your first elastic load balancer. Now if you click on Get Response again, you will see a set of different IP addresses. And as you might have guessed it, these two IP addresses belong to your second elastic load balancer. So you can see that it is going to balance the traffic between instance 3 and instance 4. And same with the other IP address. So you don't have to purchase the domain to test the Route 53 functionality. You can always test your record set using the check response option for Route 53. Hi there. In this video, we are going to learn about latency-based routing policy. If your application is hosted in multiple AWS regions, this policy helps improve performance for the users by serving their request from the AWS region that provides the lowest latency to the user. So how does it do it? Well, first you create a latency records for your resources in multiple AWS regions. Then, when the Route 53 receives a DNS query for the domain, it determines which region gives the user the lowest latency and then selects a latency record for that region. And finally, Route 53 responds with the value from that selected record, such as the IP address of a web server. We are going to see this in a live demonstration in just a few minutes. The scenarios in which this policy is useful is basically any application that is deployed in multiple regions and requires a response from the resources in terms of milliseconds or even microseconds. For example, streaming media or online gaming applications would definitely benefit from latency-based routing policy. To demonstrate how the latency-based routing policy works, I will be setting up this scenario. Basically, I'll be creating two A records. The first A record will be a latency record for US East 2 region. I will be creating an instance in that region as well. The second A record will be a latency based record for EU West 3 or Paris region, which will have an instance created in that region as well. After setting these A records, when a user tries to go to vislabstest.com, the Route 53 is first going to see the region to which the user belongs. In this case, it's US East 1. The Route 53 is going to then calculate the latency between the region of the origin, which is US East 1, and US East 2. Let's say that latency is X. Route 53 is also going to calculate the latency between region US East 1 and EU West 3. Let's call that as Y. If the X is less than Y, that means the latency between US East 1 and US East 2 is lesser, so the traffic will be routed to US East 2 region. However, if the latency Y is less than X, that means the latency between the regions US East 1 and EU West 3 is lesser, so the traffic will be routed to EU West 3. So in this scenario, most likely the traffic will be routed to US East 2 region because geographically these two regions are closer to each other. However, this is not always guaranteed. So note that the latency calculation between hosts on internet can change over time as a result of changes in network connectivity and routing. Also, latency measurements performed are over a period of time. It's not at that moment when the request comes. Similarly, let's say that in this scenario, a user from EU West 2 region or London region sends a request to wislabstest.com. The Route 53 is again going to calculate the latency between EU West 2 and US East 2 as well as between EU West 2 and EU West 3. Most likely in this situation, the latency between EU West 2 and EU West 3 is going to be lesser, so the traffic will be forwarded to the instance in France or in Paris region. Let's create this scenario and see what happens. I am in AWS Console and in Ohio region, I have created an instance that is instance 1. If you go there, it is going to display a text as this instance is in USA. Similarly, in the Paris region or EU West 3, I have created another server which just displays a text instance is in France. Now let us go to Route 53. Go to the hosted zone and let's create a record set. Keep the type as a record. I'm going to reduce the time to live. The value for the first record is going to be the IP address of our instance that is in United States of America. Select routing policy as latency. Now select the region to which this instance belongs. It has automatically selected US East 2, so I'm going to keep that. Give it an ID. Go ahead and create it. Similarly, let us add a record for Paris region. Select the region to which this instance belongs. Give it an ID and create it. Now let us go ahead and test this using the test record set feature of Route 53. Select the type as a record. Now here is what I'm going to do. I'm going to use an IP address that belongs to a region, let's say in Canada, and see where the request gets routed to. I'm going to use this website which gives me few IP addresses that belong to Canada region. So just grab any IP address, go to Route 53 and use this as the resolver IP address and hit get response. And you can see that the response returned by Route 53 is an IP address that belongs to the US West 2 region. Now let us select a region that is closer to Paris region. How about London region? So here I have few IP addresses that belong to United Kingdom. Let's grab any one of them. Use that IP address as the resolver IP address. And there you go. The response returned by Route 53 is the IP address that belong to the instance in Paris. So it is evident that the requests are getting routed based on the origin IP addresses region and the two regions in which we have set up the latency records. Go ahead and play with it. Use different IP addresses that belong to different regions and see where the request gets routed to. You will notice that the latencies can be calculated based on the position where the regions are, and more often than not, the request will go to the region that is closer to the origin of the DNS query. And that's exactly how latency-based routing works. Hi there. In this video, we are going to learn about geolocation routing policy. And as the name suggests, in this policy, the logic of routing of the traffic is determined by the location of the originator of the DNS query. So, quite simply, the traffic will be routed based on the location of the origin of the DNS query. For example, you can configure the record sets such that the traffic coming from an IP address that is in United States of America will be routed to the resource that is an elastic load balancer or an IP address defined in, say, US East 1 region. Similarly, traffic coming from an IP address, say from Singapore, will be routed to an elastic load balancer or an IP address in the Asia Pacific Southeast 1 region. If Route 53 cannot identify the location of the DNS query, and this is very important, it will route the traffic according to the default record. If there is no default record defined, Route 53 returns a no answer response for such queries from those locations. This makes sense because there is no mapping defined for this kind of situation, right? Now, which scenarios will this routing policy be useful? There are plenty. For example, let's say if you want to localize your content and present only some or all of your website in a particular language of your users, or to restrict the distribution of the content to users belonging to specific country, or even to promote certain location-based events from a server that belongs to a particular location. To demonstrate how geolocation routing policy works, I'm going to set up the environment like this. I'm going to create 3 A records. The first A record will route the traffic to instance 1 if the origin of the query is United States of America. The second A record will route the traffic to instance 2 if the origin is Singapore. And the third A record will be a default record where the query from rest of the world will be routed to instance 3. I am in the AWS console and I have created few EC2 instances. These EC2 instances just show the instance number, instance 1, instance 2 and instance 3. Very simple. Now let's go to Route 53. Go to the hosted zones, select your hosted zone, and let's create a record set. Here I'm going to create a record set for the zone apex. Keep the type as a record. I'm not going to alias it to any AWS resource. The time to live, I'll change it to 10 seconds. Now the value for the first record will be the IP address of instance 1. Routing policy will be geolocation. Click location and select United States of America. Now note that only for United States you can select sublocation. The sublocations will be all the states that belongs to United States of America. I'm going to create this record set that will handle the traffic coming from any state from the USA. Give it a name. And create it. Let's create another record set for Singapore. Use the IP address of instance 2. Routing policy will be geolocation and select Singapore as the location. Now at this moment, let us not create the default record and let's see what happens. Now there are two ways of testing this. You can either VPN using an IP address that belongs to United States and later to Singapore, or we can just use the test record set feature that is offered by Route 53. Let's do that. Click on test record set. The hosted zone is vislabstest.com. Keep the record name as blank. Select the type as a record. And now we are going to use the IP addresses belonging to these countries as resolver IP address, and we'll see what response we get. Now for this demonstration purpose, I'm going to use a website that actually gives you the major IP address blocks that belong to a particular country. So for our test, you can grab any IP address from this. Go back to Route 53 and use it as the resolver IP address and hit get response. And you can see that the response returned by Route 53 is an IP address that is of instance 1. Let's test that. Now let's go ahead and select an IP address that belongs to Singapore. Grab any random IP address from this. Use it as the resolver IP address. Hit get response. And you can see that the response returned by Route 53 is an IP address of instance 2. Now, let's go ahead and select an IP address that belongs to any other country than these two. I'm going to select an IP address that belongs to United Kingdom. And you can see that the response this time is written as empty. And why is that? Because we do not have our default record set. So let's go ahead and create that. Keep the zone apex, change the TTL. You do not have to change the TTL, but I'm just keeping it low for this demonstration. The value will be the IP address of instance 3. The location will be default. And create it. Now we'll go back and test our record sets. This is the IP address of United Kingdom. Now when you click get response, after a few seconds, you will get the response as the IP address of instance 3. So that is the gist of geolocation routing policy. The logic is to route the traffic based on the geolocation of the origin of the DNS query. Hi there. In this video, we are going to learn about failover routing policy. This is a very simple one to understand. This policy lets you route the traffic to a primary resource when that resource is healthy and to a secondary resource when the first resource is unhealthy. So as part of this routing policy, you are going to have two resources. One is primary and the second is secondary. The scenario for this policy would be, for example, if you have an application that is hosted on a hybrid cloud, that is some part is on, let's say, AWS and some part is on on-premises server. If for some reason your instance in the cloud fails, the traffic gets then routed to an on-prem web server. Now this policy has an important functionality associated with it. That is health check. What is a health check? Health checks basically monitor the health and performance of your web applications or web servers and some other resources. So basically it monitors the health of a specified resource such as a web server or the status of any other health checks or the status of an Amazon CloudWatch alarm. We are going to see how an health check works in just a few minutes. After you create a health check, you can get the status of the health check and configure DNS failover. Now note that if you want to receive a notification when the status of a health check changes, you can configure an Amazon CloudWatch alarm for each health check. To demonstrate how a failover routing policy works, here is what I'm going to set up. I will be creating two A records. One will be primary and the other will be secondary. Each record will point to a particular EC2 instance. I'm going to also associate a health check to the primary A record. So as long as root 53 determines that the instance 1 in the primary A record is healthy, it is going to route all the traffic to that instance. As soon as the health check reports that this instance is unhealthy, for example if it stops or terminates, root 53 is going to route all the traffic to the secondary instance. That's exactly how a failover routing policy will work. Let's go ahead and test this in AWS Console. In the AWS Console, I have reserved a couple of EC2 instances. Instance 1 just displays a text instance 1 and instance 2 displays a text of instance 2. Now let's go to root 53. Click on hosted zones. Now before we create a record set, let's go ahead and create a health check first. Create a health check. Give it a name. This is going to be health check for our primary record. We are going to monitor an endpoint, that is an EC2 instance, using this health check, but you can also monitor a status of another health check, or as I mentioned, you can monitor a state of a CloudWatch alarm. For our demonstration, just select endpoint. We are going to check the health of an IP address, that is going to be our instance 1. So keep the protocol as HTTP and use the IP address of instance 1 here. Host name is optional, you can keep it blank. Let the port be 80 and path as root. So the health check is going to communicate with our instance 1 via the port 80 and it is going to see if the default page on that server is reachable or not. Click next. At this stage, you can create a CloudWatch alarm that notifies you once your health check returns the status of an instance as healthy or unhealthy. For our demonstration purpose, we don't need an alarm, so select no and create this health check. Now note that the initial status of that health check is going to be unknown because it takes some time for the health check to monitor the health of the EC2 instance. If you refresh after say 2 to 3 minutes, the status should be healthy. Okay, so our instance is now healthy and the health check is reporting that instance as healthy. Let's go to hosted zones. Let's create our primary record set. Keep the name as zone apex, the type as a record. Let's reduce the time to live to 10 seconds. The value that we are going to use is the IP address of instance 1. Routing policy will be failover. This record type is primary and let's associate our health check with this record set. Let's go ahead and create it. Now let's go ahead and create our secondary record set. Note that you need to keep the same name that you used in your primary record set. So you cannot create a subdomain here. Let's reduce the time to live. The value here will be the IP address of second instance. And this record type is going to be secondary. Now you can associate a health check with secondary, but it is not really needed because we are going to monitor the health of the primary instance in our demonstration. So just keep it as is and create it. Okay, so what have we done with these records now? Now if you go to vislabstest.com, the traffic should take you to the instance 1. And once that instance fails, the traffic should go to instance 2. Let's try that out. Now you can use the test record set functionality of Route 53, or you can directly go to vislabstest.com. This time, let's test vislabstest.com. And you can see that the traffic is going to instance 1 only. That is our primary instance. Now let's go to EC2 and make this instance as unhealthy. Go ahead and stop instance 1. Okay, the instance 1 is now stopped. Now let's go back to Route 53 and see the status of the health check. Now give a couple of minutes to this health check to come to know that the instance is unhealthy. And there you go. The primary health check is now reporting the status of instance 1 as unhealthy. If you select it, the IP address is of instance 1 and the status is now unhealthy. So let's go ahead and see where the traffic for vislabstest.com takes us to. So go ahead and refresh this. And there you go. You can see that immediately the traffic is getting routed to instance 2 because our instance 1 is unhealthy. So that is the gist of failover routing policy. It's very simple. As long as the primary instance or the instance or the target that is as part of the primary record set is healthy, the traffic will go there. Else the traffic fails over to the secondary instance or resource in the secondary record set. Hi there. In this video, we are going to learn about multi-value answer routing policy. This policy is a modified version of a simple routing policy. Just like simple routing policy, this policy basically lets you configure Amazon Route 53 to return multiple values such as IP addresses in response to a DNS query. However, it is different than simple routing policy because this policy lets you check the health of each resource. So Route 53 returns only the values that pertain to the healthy resources. This was not possible in simple routing policy's basic records. Note that this policy behaves in similar way to a load balancer. However, it is not a substitute for a load balancer. Route 53 responds to DNS queries with up to 8 healthy records and gives different answers to different DNS resolvers. Now note few important characteristics of this policy. If you associate a health check, Route 53 responds to the DNS queries with the corresponding IP addresses only when the health check is healthy. However, if you do not associate a health check, Route 53 always considers that record to be healthy. So it is very important that you associate a health check so that you do not get the IP addresses that belong to any unhealthy instances. Another thing is that if you have 8 or fewer healthy records, Route 53 responds to all DNS queries with all the healthy records. So remember, 8 or fewer healthy records. However, if all the records are unhealthy, Route 53 responds to DNS queries with up to 8 unhealthy records. You can use this policy in virtually any web application that is hosted on multiple web servers. To demonstrate how multi-value answer routing policy works, I am going to set up a scenario like this. I will be creating 4 A records, each targeting to a separate EC2 instance. Each record will have its own health check associated with it. So health check 1 will monitor the health of instance 1, health check 2 will monitor the health of instance 2, etc. Now, as long as each instance is healthy and as long as each health check reports that instance to be healthy, Route 53 is going to return all the IP addresses as an answer to the DNS query. But let's say two of them become unhealthy, so two health checks have failed. In that case, Route 53 is going to return only the IP addresses corresponding to the healthy instances. Let us see how this works in the AWS console. In AWS console, I have created 4 EC2 instances. Each instance is displaying an instance number associated with it. Instance 1, instance 2, instance 3, and instance 4. Now let us go to Route 53. Go to health checks. Here I have created 4 health checks, each monitoring a separate EC2 instance. So I have health checks for instance 1, 2, 3, and 4. Currently, all instances are running, and that's why the status of all health checks is healthy. Now let's go to the hosted zone. Here I have already gone ahead and created 4 record sets. Each record set has a value corresponding to each instance. In this case, this IP address corresponds to instance 1 as well as the health check that corresponds to instance 1. Similarly, I have created another record for instance 2, instance 3, and instance 4. Now let us go ahead and test this using the test record set option given by Route 53. The hosted zone here is vizlabstest.com. The type that is selected is a record. Just do not use any resolver IP address and just hit get response. And you can see that the response returned by Route 53 includes all the IP addresses. That means all instances are healthy and their corresponding IP addresses are returned to the DNS query. Now let's go ahead and make two of the instances as unhealthy. Let's go back to EC2. Grab a couple of instances and let's make them unhealthy by stopping them. Okay, so I have gone ahead and stopped instance 1 and instance 3. Let's go back to Route 53. Let's go to health checks. And just refresh the health check. Okay, as shown by the health check, instance 1 and instance 3 are unhealthy. Now let us go back to hosted zones. Let's test our record set. Select the type of record as a record and hit get response. Route 53 is now responding only with the IP addresses that correspond to the healthy instances. That is instance 2 and instance 4. So that is the gist of multi-value answer policy where you define health check for each record, and Route 53 is going to return only those IP addresses or only those resources that are healthy.